Hello everyone and welcome to ITLS Academy Empower the Youth. So today in this lecture we're going to study about X-ray fluorescence spectroscopy. So we have already discussed about different types of spectroscopy like UV visible spectroscopy. We have discussed about the infrared spectroscopy. So today we will going to study about our next analytical technique of that is X-ray fluorescence spectroscopy. So before starting with this topic, let me give you a brief introduction of what is a spectroscopy. So spectroscopy, it includes the study of interaction of electromagnetic radiation with matter. Okay, so the characterization of any chemical compound on the basis of their spectral properties, they are done by using spectroscopy. So basically this spectroscopy, it is a technique of that is used for the qualitative estimation, or you can say identification of biomolecules. They are done with the help of this type of spectroscopy. And of course in this spectroscopy we use different types of radiation like visible radiation, that is a light. And if you talk about the in the recent time, in the recent era, so but spectroscopic techniques have been very refined, so therefore their scope are becoming very broader. Nowadays it is used to examine the behavior of chemical substances also. So after electromagnetic radiation such as gamma rays, X rays, or you can say ultraviolet rays, infrared rays, radio waves and microwaves. So these all by using these techniques, different types of intermolecular bonding types or molecular changes which occurs during any enzymatic reactions, and the mitochondrial electron transport chain, etc., can also be obtained. Okay, so this technique is very specific in the analysis of qualitative and quantitative measurement of biomolecules, even in the impure sample. So this technique doesn't need a very pure sample, so you can estimate the qualitative and quantitative measurement of biomolecules in the impure sample also. Okay, so this make it a very convenient and it can be done very rapidly. So that is the reason their scope is becoming very broadened. Okay, now let's quickly understand now let's quickly come to our main topic of today's discussion, that is X-ray fluorescence spectroscopy. So what do you understand by this X-ray fluorescence spectroscopy? So here two terms is being used. One is fluorescence and second is X-ray. So if you talk about fluorescence, so we all are familiar with the meaning of fluorescence. So fluorescence means emission of light. What does fluorescence means? Fluorescence means emission of light. Okay, so fluorescence means the emission of light. So a compound, they observe energy in UV range, UV region, and fluorescence in the visible region. So if we talk about fluorescence, so we have already discussed that fluorescence means emission of light. Emission of light basically from a molecule after the absorption of the radiant energy. Okay, so X-ray fluorescence spectroscopy, in short we can also say that it is XRX, that is X-ray fluorescence, is a non-destructive analytical technique used to determine the elemental composition of material. So basically this is a non-destructive, this is a keyword of this definition. If you want to write the definition of, if the definition is asked in the examination, so just mention this term, non-destructive analytical technique. So this is the keyword of this definition. and which is basically used to determine the elemental composition of a material. Now let's move to the next and let's see the detail of what is X-ray fluorescence. So already told you that X-ray fluorescence can also be known as XRF, and it is a non-destructive analytical technique. And here the fluorescence refers to the emission of light from a molecule after the absorption of radiant energy. Okay, now before understanding this paragraph, let me tell you, when a molecule absorb any radiant energy, okay, so let's say this is a molecule. So when this molecule is absorbing the radiant energy, okay, so its electrons are elevated to the excited state. So let's say it has a electrons. So this the electron of this molecules, they will go to the excited state. Let's say the electron is here in the ground state, but after absorbing the radiant energy, the molecules from the ground state, it gets elevated to the excited state. Okay, excited state. So if there is no chemical reaction, dissociation, rearrangement, or energy transfer by collision, the molecule return to the ground state. So there is a possibility also, as if you have heard my previous lectures, so here I have told you about the possibilities also. What are the possibilities that the molecules can return to the ground state? So if what are the basically, see, after let me tell you in a very simple language. This is a molecule, okay, so this molecule, if this molecule observe the radiant energy, so the electrons that is present in this molecule, they will go from the ground state to the excited state. Okay, after the molecule moves from the ground state to the excited state, okay, so up the molecule is here, but if the molecule wants to come back to the ground state, three things should be there. What is there? There should be no chemical reaction, there should be no dissociation, or there would be no rearrangement or energy transfer by collision. So because of these possibilities, the molecule return to the ground state and the excessive energy is lost as a heat. So after that, the energy that will going to loss through the in the form of heat. Okay, so the energy is lost as heat or light. Okay, so how energy is lost? So energy is lost in the form of heat or light. Okay, heat or light, that is photon of energy. So photon of energy, that is known as H. Okay, so the emission of light is called fluorescence. Okay, so this is the fundamentals behind the fluorescence, X-ray fluorescence spectroscopy. Now the X-ray fluorescence spectroscopy is an analytical technique that uses the interaction of X-rays with the material to determine its elemental composition. So here the interaction is taking place. So interaction is taking place between the X-rays with the material to determine its elemental composition. So X-ray fluorescence spectroscopy is suitable for solid, liquid and powders, and in most circumstances it is a non-destructive, that we have already discussed in the previous lecture, that it is a non-destructive analytical technique. So XRF spectroscopy is a very effective method for qualitative as well as the quantitative analysis of material composition. So there are basically two types of XRF, that is energy dispersion and wavelength dispersion. Okay, so the two methodology is energy dispersion and wavelength dispersion. Now let's move further and let's see what is a X-ray. So X-rays form part of a electromagnetic spectrum and are characterized by energies lying between gamma and ultraviolet radiation. So wavelengths are typically in a range of 0.01 to 10 nm, which is equivalent to energies of 125 kV to 0.125 to keV. So what is X-ray? So X-ray, it is a part of electromagnetic spectrum. As you can see, this is electromagnetic spectrum. So X-ray, it is a part of electromagnetic spectrum, and they are characterized by energies that is lying between the gamma rays and ultraviolet radiation. Okay, so wavelength, they may range in a different range, that is between 0.01 to 10 nm, and energies that which is equivalent to the energies of 125 kV to 0.125. So this is the electromagnetic spectrum, and X-ray, it is a part of a electromagnetic spectrum. So if you see the overview of the diagram of electromagnetic spectrums, and so there are different types of radiations, like like radio waves is there, microwaves are there, infrared, ultraviolet, even X-rays, gamma rays, and every rays have its own applications in different field. Okay, now let's move to the next, that is the visible spectrum. As you can see, this is the visible spectrum, and their wavelength is ranging from the, as you have seen here, the wavelength is ranging from 0.01 to 10 nm, and energy from 125 to 0.125. Okay, so electromagnetic radiation, it is a very short wavelength, that is called as the X-ray, or you can say that X-rays are produced when electron jump from the highest energy level to the lower energy state. So if I can write it here, that if how X-ray are produced, X-ray production. Okay, so if you see the X-ray production, so X-ray production, X-rays are produced when electron, let's say electron is here in the higher state. So when the electron jump from the higher state to the low energy state, so X-rays are formed. Okay, so who was the father of X-rays? You have to write it in the comment section below. Now let's move further and let's see the interaction of X-rays with the substances. So now comes how X-rays, they interact with the substances. So when X-ray irradiate to a substances, some of the X-rays passes through the sample, and some X-rays are absorbed by the substances. So the absorbed X-ray, they interact with the substance in a atomic level and cause various phenomena such as scattering, releasing photons, electron, fluorescent X-rays. Okay, so how the interaction of X-rays take place with the substance? So whenever the X-ray irradiate to a substances, or you can say whenever the X-ray it passes through any substances. Okay, so so some of the X-rays, they are absorbed by the substances, and some of the X-rays, they are radiated by the substances. They just pass through the substances and some get absorbed. So the absorbed X-ray, what they do, they interact with the substances in the atomic level. So after the interaction of X-rays with the substances in an atomic level, they causes of various phenomena, like for example scattering and releasing of photons, electron and fluorescent X-rays. Okay, so this is how the interaction of X-rays take place. So let us understand with the help of the figure. So this is the interaction of X-rays with the help of interaction of X-rays with the substances. So let's say primarily X-ray, they fall on the substance. Okay, so some of the X-ray, what they do, they get passed through these substances and some get absorbed. So with some they relay the scattering, means without the energy loss. This some they get Compton scattering is there. Compton means with the energy loss. Some is the some types of scattering that I have already said now. There are they causes various phenomena like scattering, releasing of photon. So here if you see, scattering is also of basically two types. Okay, first is without the energy loss and second is with the energy loss. Okay, then some of the other phenomena are like photons as their auger electron, fluorescent X-ray, some get absorbed. So this is how the interaction of substances, X-rays take place with the substances. So again this is very important, just mark it down somewhere, that the absorbed X-ray, they interact with these substances in the atomic level and they causes various phenomena in the sense releasing of photon, electron, fluorescent X-rays and scattering. So we have seen all the phenomena as in this diagram, that how the X-ray they interact with the substances. Okay, after interacting with the substances in the atomic level, so there are different types of phenomena like scattering. There is basically two types of scattering is there, without energy loss and with energy loss. Photon is there, okay, then fluorescent X-rays. Okay, so these are certain phenomena that take place when the interaction of substances, electron get interact with their substances. Now further moving to the X-rays, fluorescence processes. Okay, now what is the process? So a solid or a liquid sample, it is irradiated with the high energy X-rays from a control X-ray tube. So I have already told you that basically solid or liquid samples are used. So the solid or a liquid sample is taken and the samples, they get irradiated with the X-rays, and the X-rays from a control X-ray tubes. Then when an atom is in the sample is stuck with the X-ray of sufficient energy, so the substances, or you can say the samples, so the atoms that are present in the samples, when they stuck with the X-rays of sufficient energy, means they get sufficient energy greater than the atom of K or L shell bringing binding energy. So what does the electron do? The electron of the atoms, the electron from one atom's inner orbital shell is dislodged. Okay, after dislodging, the atoms regain stability, filling the vacancy left in the inner orbital shell in an electron. Okay, so after the electron dislodged, so the atoms, what does atoms, they regain the stability. After regaining the stability, they fill the vacancy left in the inner orbital shell with the electron from one atom's higher energy orbital shell. So the electrons, they drops the energy state by releasing fluorescent rays. So the energy of X-ray is equal to the specific differences between the energy of two quantum states of the electron. So the measurement of this energy is done by the help of X-ray analysis. So the X-ray it is very much equal to the specific differences in the energy between the two quantum state of the electron. Okay, so the measurement of this energy is the basis of X-ray analysis. Now, like this, when the incident radiation from a primarily X sources falls on samples, so the matter, so the atoms of the samples, they get when they get the sufficient amount of X-rays. So what they do, they the electron from one atoms in the orbitals comes is dislodged. Okay, as you can see. So this atom get the like if you see that K shells, so they eject the X shell electron. So then K X-ray get emitted, then it also get emitted here, also the L X-ray get emitted. So ejected L shell electron, so the in the M shell electrons fills the vacancies. Okay, so you can also understand this how the energy level and transition of electrons in a molecules take place. Let's say let's us understand this with the help of a graph. So this is the energy of molecule, and this is absorption of energy. I'm just writing it in a short, and this is fluorescence. So this is the second ES means excited state. This is the I will tell you, this is the non-radiant loss of energy, and this is the first excited energy. F means first excited energy. So as you can see, this is a diagram. Okay, this is a graph, I will tell you. So how does it take place? So if you see that a compound, what they do, they observe the energy in the UV region and fluorescence in the visible region. So in the fluorescence, they absorb the excited light is of the smaller wavelength, and the wavelength of the energy that is emitted is of the greater wavelength. Okay, greater wavelength. So the energy in the wavelength of the emitted light, then the excited light, is known as the stroke shift. So the fluorescence that is shown in the natural compound is known as intrinsic fluorescence. So there are certain chemical compound which do not fluorescence. However, the fluorescence can be detected after coupling them with a fluorescence probe. So this phenomena is known as extensive fluorescence. Okay. Now comes to the next, that is how X-ray fluorescence X-ray fluorescence spectroscopy is used in the industries. So it has a huge demand in different sectors, like in oil and gases, in metal fabricating, in automotive, aerospace, in scrap metal or recycling, in precious metal recycling, in mining and exploration, in destruction and environmental engineering. So it has a great advantages or applications in different types of field. Let us understand how it has a advantages in the oil and gas industries. So in oil and gas industries, so for a very positive metal identification of piping material, which is critical where the flow is accelerated corrosion or sulfidic corrosion is a concern. So there it has a huge demand and it is used in a great way. Then in the metal fabricating, so it is again a non-destructive element analysis. As we already know that X-ray fluorescence spectroscopy is a non-destructive analytical method. So it is used to ensure that there should be no incorrect or output specification of metal or alloy enter the manufacturing process. Then in the automotive or aerospace, for incoming inspection and the quality control of metallic and coated parts, it is used there. And in scrap metal recycling, so for the fast and accurate sorting of scrap material, like which is essential to enhance both the workflow efficiency and profitability, so there also this analytical technique is used. Then in mining and exploration, so for a quickly identifying and recovering the most economical viable resources, so this analytical technique is used. Then it has a environmental it has an application in construction and environmental engineering, so for screening, risk assessment, hazardous site modeling, and remediation, quality control. So this XRF is used. So if you see the application, so it has a great application in different industries, like in oil and gases. If you see, it has a great applications in environmental, in mining, means it has a huge application in different industries. So because of this technique or this analytical method is the scope of this method is becoming very broadened. So that brings to the end of the lecture. Let's quickly discuss some important questions based on this topic. So if you see, the first thing that in examination they can ask you what you understand by X-ray fluorescence spectroscopy, or even they can ask you what does fluorescence means. Okay, so you can just write it, the fluorescence means that the emission of light. Okay, so the next question is what are the two main methodology? In interviews they can ask you that name the two main X-ray methodology, so you have to tell the name of the two. So this is the first part, student. In the second part I will be just discussing the detail of the two methodology and how the history of the X-ray fluorescence spectroscopy. Now comes what do you understand by X-ray. Okay, in MCQs you have given examination, so you have seen they can ask you the ranges also, so you have to know the ranges of wavelength and the equivalent energies. So these questions can be made. Then they can ask you about how the X-ray they get interact with the substances and explain with the help of a diagram. So this is a diagram to explain how the interaction of X-rays take place with the substances. Then at last they can ask you about the processes of X-ray fluorescence spectroscopy, and of course with the help of a diagram. So this is a diagram to answer that. And at last how X-rays are fluorescence spectroscopy is used in the industries. So that brings to the end of the lectures. I hope you have understood the lecture. If you have any doubt, any query related to the lecture or related to any analytical technique method lecture, so you can just simply leave the queries in the comment section below. In the next lecture I'll be answering the queries. You can follow ITLS Academy on Twitter, Instagram, Facebook, LinkedIn, and you follow ITLS Academy on YouTube, and visit our website, that is www.itlsacademy.com. This is our helpline number, that is 7080833450. You can simply call on this number and get updated. You can get our app from Google Play Store. Thank you for watching. Please do like, share and subscribe ITLS Academy. Thank you.